Let's try one more example. We're given that sine theta is negative 5/13 and theta is in the third quadrant. And we want to find cosine theta. So let me try graphing out where that might be. Okay, theta is in the third quadrant. That's down here. And so it's some angle down there. I don't know exactly where it is, but I'll draw it down there. But what I'm given is that sine theta is negative 5/13, and I want to find cosine theta. Well, I have this Pythagorean identity that says sine squared theta plus cosine squared theta is equal to 1. So I'll plug in sine theta, that's negative 5/13 squared plus cosine squared theta equals 1. Negative 5/13, when you square it, the negative goes away, so we get 25 over 169 plus cosine squared theta is equal to, well, I'm going to have to subtract the 25 over 169, so I'll write 1 as 169 over 169. And then I'll subtract 25 over 169 from both sides. I'll get cosine squared theta is 144 over 169. And then if I take the square root of both sides to solve for cosine theta, I get cosine theta is equal to plus or minus square root of 144 is 12, square root of 169 is 13. So I know that my cosine of theta is equal to either positive or negative 12/13. That's all I can get from the Pythagorean identity, because it only told me what cosine squared of theta is. I can't figure out from that whether cosine theta is positive or negative. But the problem gives us a little extra information. It says theta is in the third quadrant. So knowing that theta is in the third quadrant, I look down there, I remember that cosine is equal to the x-coordinate of my angle. So cosine is the x-coordinate. Remember, all students take calculus. Down there in the third coordinate, in the third quadrant, tangents are positive, but nothing else is positive. That means the cosine is not positive, it's negative. So the cosine of theta is equal to negative 12 over 13. It must be the negative value. Because it's down in the third quadrant, that's where the x-coordinate is negative. X-coordinates are negative down in the third quadrant. So the key to this problem really is, first of all, remembering the Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. Then you plug the value you're given into the Pythagorean identity, and you try to solve for cosine theta. Once you work through the arithmetic, you get a value for cosine theta, but you don't know if it's positive or negative. Then you go over and look whether what quadrant the angle is in. It's in the third quadrant. And then you either remember all students take calculus, that tells you the pluses and minuses on the different functions, or you just remember that in the third quadrant the x values are negative, so the cosine value has to be negative. So either way, you end up with cosine theta is equal to negative 12 over 13. So that's the end of our set on the Pythagorean identity. This is educator.com.